Today we're starting 5.1, radicals and rational exponents. A lot of this stuff you've seen in the past. For example, the nth roots. Nth roots are just any root, any radical. What root is this, or each one of these? Square root. That's a times symbol. I didn't want to put an X in the middle. These are square roots. There's really 2's there that we don't write. This actually means the square root of 8 times the square root of 2. Or, sorry, square root of 12. When I'm multiplying, I just multiply the radicals. So it's square root of 8 times 12. What is 8 times 12? So I have the square root of 96. Do you know the square root of 96 off the top of your head? No. I'm going to try to factor it. 96. What can it be broken apart into? 12 and 8. What does 8 mean? 4 and 2. 2 is prime. 12 means 4 and 3. 3 is prime. And 4 for both of them is 2 and 2. 2 and 2. I look for pairs. I look for pairs of 2 because this is the square root. If it was cube root, I'd look for groups of 3. I have a pair of 2's, so I write a 2. Any other pairs? What? Another pair of 2's, so times by 2. Any other pairs? No. So I'm going to put square root. What am I left with? A 2 and a 3. 2 times 3. 2 times 2 is 4. 2 times 3 is the square root of 8 times the square root of 12 is 4 square root of 6. We did this a long time ago when we were doing quadratics, when I had you simplify the b squared minus 4ac part. Questions on this? Square root of 12 minus the square root of 75. It's subtraction in between. You can't take 12 minus 75. It doesn't work that way. I need to try to factor both of these individually. Multiplying, it's okay to put them together. Adding, subtracting, you can't. Factor 12. We already know from the last problem that it's going to be 2, 2, 3. We know that from the last problem. How about 20 or how about 75? 25 and 3. 3 is prime. I don't know why I write 35. 3 and 25. 3 is prime. 25 is 5 and 5. All right, in the 12, I have a pair of 2's. So it's 2 square root of 3 minus, I have a pair of 5, so it's going to be 5 square root of 3. What's 2x minus 5x? It's a little side thing. Negative 3x. So what's 2 square root of 3 or minus 5 square root of 3? Negative 3 square root of 3. That's it. The radical is like the variable. It's what they have in common. I have 2 apples. I'm going to take away 5 apples. It's negative 3, whatever that was. So my answer is that. Now there's this one. The computer won't put the line all the way across, so I put it in parentheses. This means the cube root of 8x cubed y to the fourth. What I'm going to do is I'm going to take each one individually. I'm going to have the cube root of 8. Actually, I'm not going to write it like this. Square root of 25. You know the answer is 5. In the calculator, I could just type square root 25. What's another way I can type it into the calculator? How can I type it as an exponent? What is it? It's not -2. It's just 1 over 2, 1/2. It's to the half power. So what would a cube root be? To the third power. So if I'm taking the cube root, I have the cube root of 8 times, technically I have the cube root of x to the 6th times the cube root of y to the 4th. I told you if you had the square root, it's actually to the 1/2, right? Now the cube root of 8, what times what is 8? 2. So the cube root of 8 is 2. That was easy enough. These ones that are a little more difficult. All right, I'm going to bring this over here, just so you see. Another way I can write this is x to the 6th to the 1/3 power. When you have an exponent to an exponent, you multiply. So it's x to the 6/3, which is x squared. What did I really do? I divided. 6 divided by 3. So what am I going to do with the y? 4 divided by 3, which is 4/3. That is my answer. 2x squared, y to the 4/3. Another way I could have written this. 2 means 2. X squared means x squared. Another way I can write 4, or y to the 4/3, is the cube root of y to the 4th. The numerator stays with the variable. The denominator always tells me the root. So if I had x to the 4/5, what's another way I could write this? What root would I have? This would be the 5th root of x to the 4th. Either one works. Most of you will probably do this one, and I have no problem with it. Here's another type. Don't be scared by the radicals. What would you do in general to solve this? Not factor, distribute, FOIL. 5 times 5, 25. 5 times negative square root of t. Negative 5 times the square root of t. 5 does not go on the inside. It stays on the outside. If I have 5 times the number of apples, what do I have? 5 times the apples. 5 apples. Okay, done with that. What's square root of t times 5? Plus 5 square root of t. Now square root of t times negative square root of t. They will cancel out, and I'm left with negative t. All right, I'll show you. Square root of t times square root of t. It's negative because one's positive, one's negative. When you multiply, it's like I showed you on the first slide, right here. I have 8 times 12. What do I have in this one? T times t is t squared. Well, square root, another way I could write it is to the 1/2 power. What do I do when I have something a power to a power? Multiply. Now I'm going through the long way just so you see it. T to the 2 over 2, which means it's t to the first, which is just t. In other words, when you take a square root times the same square root, they cancel each other out. Back here, the square root of 8 times the square root of 12 is not 96. The square roots did not cancel each other out. But if this was the square root of 8 times the square root of 8, my answer would be 8. Because 8 times 8 is 64. Square root of 64 is 8. I'm going to try to simplify this. What do you mean? The negative 5 square root of t and the positive 5 square root of t cancel out. I am left with 25 minus t. Can I solve this any further? Why can't I? Can't combine unlike terms. And what is this called? The end. This is called an expression. You can't find out what answers are for expressions without knowing what other things are. If I made this equal to something, then I could solve it. Equations you can solve, expressions you can only simplify. I already told you this. 40 to the 1/5. How do I type it in the calculator? Carry it up. This is where you have to be careful. It has to be in parentheses for 1/5. I will show you the difference. This means it's 40 to the 1/5 power, 2.091. If I take 40 to the 1/5, when I hit enter, I get 8. What is the calculator thinking? Right, the calculator thinks you're taking 40 to the first, which is 40, then dividing by 5. If it's going to be a fraction as an exponent, you need to put in parentheses. This also means the 5th root of 40. How do I do 5th root in a calculator? 5 math 5. That's what the x means. You put this number first, then math 5, then 40. And I get the 2.091. You need to know either way. How about this one? 225 to the 1/15th power. See if you can do it both ways. First way, the easy way. 225 to the 1/15th. I can't stress this enough. Be careful with the parentheses. Something dumb's going to cost you points. 1.435. The other way, I just type 15 math 5 to 25. 1.435. I'm going to change this problem now. Actually, I don't want to make that 11. Try this one. Both ways. Both ways should give me the same answer. I mean, the first one should be easy. 225 to the 2/15. It's typing it in the second way I have to be careful. How do you think I type in the other one? 15, math 5. It's still the 15th root. 225 squared. I either put caret 2 or I just write the x squared button right here. All right? Top number stays with the base. The denominator of the fraction is the root. So try this one both ways. All right, the first way, 30 to the 2/3. 9.655. How do I type the other way besides Jalen? 3 math 5 30 squared. Same answer. I know if I did it both ways and I get the same answer, you're good. Are you okay with the basics here? Don't get worried, just look. This is what we just did. If I have c to the tk, it is the same thing as the k root of c to the t power. And the t can also go on the outside. If I took this problem here, 3 math 5 30, put that in parentheses, and then squared it, still get the same answer. I'm just letting you know, nothing to be confused about here. I know you see all the letters and you get lost. Here's the rules. You've seen all these rules before. You know most of these. If I have c to the r times c to the s, I have the base is the same. They both have c's. If you're multiplying, you add the exponents. What do you do if you divide? If you divide, you subtract. The next one, I think, was Taiwan already set. Exponent to an exponent, you multiply them. We did this one on the root problem, the cube root of that 8, x to the 6 problem. Exponents are distributive. If I have CD, all of that to the r power, it's c to the r, d to the r. Same thing for fractions. It's distributive, as long as d is not 0. If I have c to the negative exponent, this is the one you got to be careful of, the negative exponent. If I have 5 to the negative second power, if I have 5 to the negative second, it tells me it's 0.04. If I hit math, enter, enter, I get 1/25. Where do I get the 25 from? Where did I get this 25 from? Looking at this. 5 squared is 25. If I have a negative exponent, this is actually over 1, right? Just means this actually belonged on the bottom and would be 1 over 5 squared, which is 25. Negative exponents means you belong on the opposite side, numerator, denominator. And the last two, if I put numbers in, it doesn't make sense. If I have c to the r equal to c to the s, then r has to equal s. If 5 squared equals 5 squared, then 2 has to equal 2, of course. If I have c to the r and d to the r, then C has to equal D. Here's the first problem. This is just putting everything I just told you into one problem. I have 8r to the 3/4 power times s to the negative third, all to the 2/3 power. First thing I do is look on the inside. Is there anything I can do? Is there any other coefficients? Any other r's? Any other s's? So the next thing I'm going to do is distribute. This 2/3 exponent will go to all three terms. So I'll have 8 to the 2/3. What do I do with exponents to exponents? Multiplying. So I have r to the 3/4 times 2/3. And s to the negative 3 times 2/3. Why? It's only when you divide. Eight to the 2/3. Let's see. 8 squared 64. The cube root of 64 is 4. You can type it in the calculator, you'll get 4. All right, I'm going to try to simplify this right here. What do I get when I do 3/4 times 2/3? Simplified. Simplified is half. So I have r to the half. What do I get here? I don't get half. It's negative 6 over 3, which is s to the negative second. A negative exponent just means r to the 1/2 over s squared. That is your final answer. Why did the s go from here to down here? Why did the 2 become positive? Well, it's on the bottom. I moved it. Because it's a negative. If I had 1 over x to the negative 5th, the negative 5 tells me, the negative tells me I belong on the opposite side. So it actually means x to the 5th. Negative exponent just means it belongs on the opposite side of the fraction. This is actually s to the negative second over 1. So it belongs on the bottom. Right, it was actually, 4r to the 1/2 times 1 over s squared. That's an s, not a 5. Which just means this over that. Here's this one. Let's give it a try. These problems, you don't worry about variables at all. What is this doing to the other ones? Is it multiplying or is that an exponent? This x to the 1/2, what's happening to it? What's it doing to the rest? This x to the 1/2 power, what is it doing to these terms? Multiplying. They all are x's. So I'm going to take x times x. It's a smiley face with x's, yeah. So I have x to the 1/2 plus 3/4 plus, then I'm going to take x 1/2 plus 3/2. When I multiply exponents, I add them. All right, I need a common denominator. This would be a 4, which makes this a 2. 2/4 plus 3/4. 5/4 plus, let's see, 1/2 plus 3/2 is 4/2, which means 2. That's your answer simplified. You just have to take your time and remember the rules. If I multiply and I have the same bases, I add them. The only time you multiply is when I have exponents to exponents. Here's this one. I have the 10th root of c to the 5k times the square root of c to the negative k to the 1/2 power. That's all under the square root. If I put that bar there. What does a 10th root mean? What's another way I can write something that's the 10th root? So what does that mean then? Times by, or to the 1/10th power. Another way I can write a square root is c to the negative k to the 1/2 to the 1/2. Roots just mean it's 1 over that. What do I do when I have exponents to exponents? Multiply. So I have c to the 5k over 10 times, I have c to the negative 5, or sorry, c to the negative k 1/2, 1/2. I have an exponent to an exponent to an exponent. What do I do with all those exponents? Exponents to exponents, you multiply. So I have c to the negative 5, or sorry, I don't know why I keep saying 5. Negative k times 1/2 times 1/2. What's 1/2 times 1/2? What is it? 1/4. So it's negative k over 4. It doesn't mean you divide, it just means it goes on the bottom. That was your final step. All I did was multiplied all 3 of these exponents, and that's how I got negative k over 4. Because this right here means a 2, which means it's to the 1/2. What do I do when I multiply? Add the exponents. So I have c to the 5k over 10 plus a negative k over 4. What do I have to do in order to solve this? What's a common denominator up here? 20. So that's a 20. I'll just put the minus. What times 10 gets me 20? 5 times 2 is? So I have 10k. What times 4 gets me 20? So it's 5k. What's 10k minus 5k? C to the 5k over 20. Now simplify it again. 5 over 20 means 1/4. C to the 1/4 k, which is just k over 4. That's your final answer. It's following the little rules. There's no major problems going on. It's just going, okay, a root means it's 1 over whatever this is. Rewriting it. When I have exponents to exponents, I multiply those. And I get this. When I multiply, I actually add my exponents. So I have 5/10 minus 1/4. You can do it over here or do it in the calculator. You're still going to get 1/4 k. Last two types. This comes from geometry and algebra 2. And plus from this class, we talked about at the beginning of the year. We don't leave radicals on the bottom. Radicals do not stay on the bottom. If I have 7 over the square root of 5, I don't want a radical on the bottom. So I'm going to multiply by the radical 5, radical 5. What's radical 5 over radical 5? 1. And 1 times anything is the original thing, right? So I haven't changed the problem at all. 7 times square root of 5 is 7 square root of 5. Over what's square root of 5 times square root of 5? 5. That's your answer. I rewrote it. The shortcut way, if it's written like this, you take the inside of the radical times it by the numerator. Or sorry, you take the radical times it by the numerator. Leave the inside on the bottom. This one down here, I have 2 over 3 plus the square root of 6. I need to get rid of that plus square root of 6. So I multiply by 3 minus square root of 6. I haven't really changed the problem at all. It's the same thing. What's 2 times 3? 6. 2 times negative square root of 6. Negative 2 square root of 6 over 3 times 3 is 9. 3 times negative square root of 6 is negative 3 square root of 6. Square root of 6 times 3 is 3 square root of 6. And square root of 6 times negative square root of 6. Negative 6. What happens? The radicals here cancel out. What am I left with on the bottom? 9 minus 6, which is 6 minus 2 square root of 6 over 3. The only thing I could do if I wanted to divide, I could have 6 divided by 3 is 2 minus 2/3 square root of 6. The 3 has to go to everything. I just leave it like this. It's like when we did the quadratic formula. We left it like that. I understand it was a lot of stuff. Questions?